So normally this is what I go through when I go to a class and I'm just giving a little introduction into the game development lifecycle. Um, the kind of stuff that we go over focuses on the game development roles, such as like being a programmer or being an artist, and then the responsibilities of those different roles. We talk about what the game development lifecycle is, basically very similar to the software development lifecycle, just slightly revamped to take into account the media elements, and the different methodologies that we follow. And we talk about the framework, so specifically the Scrum framework that we follow when it comes to implementing those strategies. So the different game development roles, there are many different roles, but the main three that you need to be aware of that most game developers and producers will be aware of are the designer role, the artist, and the programmer. Many other roles can kind of fall into subcategories of these main topics. So the designer normally focuses on the user experience or the player journey. It is mostly about understanding what is fun about a game and making sure that the different elements from the art and visual style to the game mechanics all lead back to the best possible experience for the player. They normally have to be very aware of things like narrative design. So it is worth mentioning that a writer isn't a game designer, and they often, while small studios will often have the game designer act as the writer, large studios will usually have them separate. So the reason why I say a narrative designer, game designer does narrative design is similar to how a director will often take charge of a lot of the writing behind a movie, but they don't often or they don't always write the original script. So the best way of thinking about this is if I wrote a book, let's say I wrote Harry Potter, for example, the director wouldn't be J.K. Rowling. It would be someone different, whether it's the new TV show or the old movies. Their job is to take the information from the book and present it to the audience in the best possible way. Some information will be shown visually, some information will be hidden in the background, some information is implied, and some information is explicitly given. It's understanding when you need exposition, it's understanding what things you can leave out completely. So narrative design is not the same as writing in that context, that a writer just needs to tell the story. A narrative designer needs to understand how that story is presented using this medium. And games have a very flexible medium when it comes to telling stories. They basically involve every other medium. You can use music, you can use colors, you can use video, you can use text, you can use voices, you can use a narrator, you can use the actors themselves as well as players depending on the type of visual effects you use. So it's important to understand the difference. The designer is often a product owner in regards to they control the vision and the direction of the overall project. So when the artists and the programmers are implementing features, it's the designer's job to make sure that what they're making is in line with the actual plan. Especially if things go wrong and you need to make compromises or you need to sacrifice elements, it's the designer usually the one who comes in and says, this is what we have to keep, this is what we can afford to lose. Things will always go wrong, and certain things will need to be prioritized. Most of the time, the developers need to focus on their individual roles of developing, so the designer needs to take a more leadership type role and help them in the different aspects. Marketer is entirely separate from designer. However, designers should have marketing skills, and ideally, the marketer would have some design knowledge, because if the marketer doesn't have design knowledge, they have to work with the designer. The designer has the best idea of what sells, what is the selling points of this game. The marketer understands the audience and how to present the information to an audience. Therefore, they need to work together. Why it's good to have those crossover skills to say, okay, if your unique selling point is, let's say, starlight, you can interact with shadows and touch them. The marketer will say, well, how will we sell that to an audience? How will we present the information? What kind of images do we want to use? Or is this something that will appeal to younger audiences or older audiences? So there's a lot of overlap with that, which is why I put marketer not as a role for designer, but more like on the team, they will interact directly with the designer. So yeah, subject matter expert is a kind of unique run. I'll give an example like Assassin's Creed. They have historians who will come in and give them accurate historic details that they can then incorporate into the game. So these people are not game developers, they're not game makers, they are legitimate historians who have studied a subject and understand it to a high degree, um, and can use that knowledge to help build an accurate and immersive world. Sometimes you'll hire people who specialize in maths or physics or um, I don't know, even martial arts, and say we're making a martial arts game, we need actual martial artists to advise. So subject matter experts are often needed for game development, and they again usually work directly with the designers, but sometimes with the artists or the programmers. So moving on, artists can also be referred to as content creators. I lean away from that term because it's often used for content creators like influencers, but content creators meaning game assets that are put into the game. This includes um, 2D assets, 3D assets, animation, music, sound effects. There are some kind of special cases like with doing 3D or augmented video games, augmented reality. But the idea is any of these essentially elements that are used to directly interface with the player's senses, I guess is a way of putting it. So what you can see, hear, touch, smell. I know I think somebody did make a game which included like smell as a mechanic. It was part of like a abstract kind of game designs. But the idea is if it interacts with your senses, you're probably a content creator in that regard. How those so that's it's fairly easy to understand, but it's worth noting. While artists can often bounce between different industries, whether they're doing graphics arts for a website or whether they're doing 3D graphics for a movie, you too tend to need to be a specialist. Many indie studios will ask for generalists who can do a little bit of everything, especially when it comes to animation, 2D art, 3D art, and concept art. But generally speaking, bigger studios will hire a artist who specializes in environment art, or an artist who specializes in even faces. I remember, I think it was God of War had like a team dedicated to just the facial animations of the characters because of how detailed they were. Um, so it's worth keeping that in mind if you want to pursue a role as an artist. It's less stable in terms of having a job role, but it is flexible in the sense that you're likely to bounce between different studios and different companies. It's also worth noting that even to this day, many people still conflate artist and designer, because a character designer or something like a costume designer is often doing the graphics behind it. They're often making the art for it, and in that regard, they often make the decisions in how a character should look. But a designer is more about the user experience and the decisions and the logic behind these elements. You might have a designer say, this character needs to carry this weapon because it's part of their lore. This character needs to have a backpack because it's going to be part of the gameplay. And then the artist, character designer, might say, okay, the backpack is going to be red, or the weapon is going to be um, carried on their back, or it's going to be carried on their waist. So there is some overlap when it comes to character designers and artistic designers, and just the designer from a game perspective, game designer. And that conflation has confused many people. I've seen job postings on AAA studios where they say looking for a designer, and then the job description is all art-based roles, um, because they're just using the wrong term, and it does confuse people, and it does create a lot of issues when people basically. It happens when they apply for the wrong jobs, but if you read the job description, you usually get around it. But the problem that I've encountered more often is people doing the wrong courses. I was advised when I was quite young, actually, if you want to be a designer, be a designer. Because what a lot of people were doing, and I still see it today, they want to be a designer, so they take an art course. Or they want to be a designer, so they take a programming course. You need to actually take a design course. They're completely separate skills. And if anything, it's the most important in regards to a course, because the technical knowledge, or I would say the specialist knowledge, is different, and it's much harder to self-teach as opposed to art and programming, where it's easier to learn from a book, or it's easier to learn by just practice. Um, so programmer is the easiest one to describe. You get back end, who mostly focus on like the system, front end that mostly focus on the visuals and controls and interfaces, full stack developer that essentially works on a bit of anything. It's worth noting that QA or dedicated testers are not programmers, but most programmers will do dedicated testing, which is why sometimes I'll refer to a tester as a developer, because you are usually a programmer who does testing, or you are usually essential to the development process. But you do have QA and dedicated testers who have no programming skills at all, who are just there to make sure the quality is to standard. So many testers are developers, but not all testers are developers. So it can be a little bit ambiguous there. Um, Also worth mentioning, things like web developers or specialist developers like AI, VR, or augmented reality. These are areas that you will probably have to study that area specifically or do courses specifically on those tools, because they're just not used in general practice. So most programmers, whether you're front end, back end, or full stack, will be expected to learn certain core skills. Um, and I do a separate talk on what those core skills are. But in regards to um, that's kind of just being a generalist. In regards to being a specialist, you're probably going to have to study that as a specific field. And if you want a job in that, you're going to need to study those areas explicitly as well and show experience and a portfolio that shows those dedicated abilities. Um, so, with that said, the roles or the responsibilities of each, I won't go into too much detail here. I just want to kind of give an overview. But the designer is usually going to be doing a lot of research in terms of understanding similar products to what you're working on, understanding rival products in the industry, what the audience likes, what they dislike, what kind of feedback they give. There's going to be a lot of communication between different members of the team, so communication skills are going to be very important here. I mentioned before, time and project management. They're going to take a kind of leadership type role, and need to have an understanding of like storyboarding and laying out information. Tools that are useful. Industry standards tools like Jira and Confluence are what a lot of companies will use. There are free tools like Trello. I've actually just used Outlook for managing tasks as well. I find that if you do reoccurring meetings, it's a good way of organizing tasks, adding details, which will then reiterate for each meeting. You can remove those details and so on. You can invite people to it so other people have a vision, can see what you're doing. Google Docs is another way, a useful free tool for sharing design information such as your premise, your game design documents, and other key details amongst your team. I also recommend tactile game design, something that I cover in my other videos. Things like using Lego or cards or D&D, things that you're using your hands to develop to show the design and layout of your ideas. It's because you're not expected to have the technical skills to draw or to program or to implement. Using just something you could just pick up and say, this is what I had in mind, is a really useful way of doing it. With artists, as I said, it's all about being a specialist. So you might be a character or clothes artist. You might need to deal with foliage or fauna, that is plants or animals, real or fake. Structures and objects is usually a good place to start. They tend to be more closely related to geometric shapes. Textures and materials are important to understand. You will usually, if you're doing 3D modeling, you're usually going to be expected to do some degree of texturing and understand how materials work in the game development software. But there might be someone else who comes in to specialize in high degree textures, especially for things like water or flowing hair, which is a little bit more complicated than your standard textures. 2D and 3D animation, again, they're separate, but they're specialist roles, as well as UI graphics, fonts, anything front end, like scores, health bars, custom fonts, all those kind of things is usually something that will be a specific skill set of a specialist. 3D Studio Max and Maya are typical industry standard tools. Illustrator and Photoshop for the 2D equivalent, but Blender is a powerful industry level tool that's free. Paint is a free tool that can help you just do basic textures and basic UI graphics. And there are other free tools like Wings and Animator and stuff like that, but Blender pretty much covers everything in that regard. When it comes to being a programmer, I'm kind of only covering the basics here, but I would say hello world, basic, make text appear on the screen, understand the principle that is behind CRUD, which is to create, read, update, and delete. It's to say any programming aspect, such as a class, you should be able to create a class, you should be able to read from that class, update it, and then delete it when you're done. If we've got a variable, you should be able to create a variable, read from it, update it, and delete it. So it's just whatever you're working on, you should be able to follow those 4 principles. Object-oriented programming is a standard. If you're just starting out, you want to learn it, but you will have a hard time finding work if you don't already have a strong grasp of object-oriented game programming. Just to name them off, that's inheritance, encapsulation, polymorphism, and abstraction. So you're going to need to learn those. At a more advanced level, so like intermediate to advanced or to senior programmers, you're looking at design patterns, which is like basically the optimized ways to implement certain features. When you get started, you just want it to work, but eventually you want to learn how to make it work well, how to optimize it, make it run more smoothly. Common game programming tools would probably be C# and JavaScript, though Java and C++ are often used, especially for back-end programming and more complicated tools, like if you're doing like physics programming and stuff like that. HTML isn't, you can learn HTML, especially combined with JavaScript, to do basic web development as on top of that. When I originally used to do this talk, I didn't even include that bit. I just kind of jumped straight to the software development lifecycle. But I thought it'd be important to add that in, so I'm kind of experimenting with a new presentation here. I'll see if this is better than my old one or not. But the software development lifecycle are the consistent phases of development that adapt to different types of projects, where each phase serves a different purpose. Now, I mentioned earlier, we're going to talk about the game development lifecycle, because games are going to be a type of software, like most of the time, at least in this context, but there are slight differences to how we perceive it, but the cycle is actually the same. It's just what takes place in those different phases is going to be altered. So we have the premise phase. That's going to be what my next video is going to be about. It's going to be establishing a good premise, understanding the core details that you need to get started. This is going to be the main task of the game designer. They need to understand things like what is the goal, what is the definition of done, what are the core selling points, what is the basic plot, what is the visual style that you're going for, and put that together in a single document, usually a single page document that everyone on the team can refer to make sure that everyone is on track when they go into development. The planning phase is about taking that document and expanding it and going into details, taking the core goals and breaking them down into achievable objectives, understanding where the priorities lie, understanding how we're going to tap into what makes this game fun, how is these mechanics and these features and these plot points going to directly affect our audience. You want to know how tasks are going to be addressed and in what order, what resources that you have available, money, time, people, skills, etc. And it's just about being organized and using tools that are available to manage the team and get things going. There is a lot more to it than that, but that's just a quick overview. Next is the actual implementation. There's certain strategies for implementation that we talk about, especially when it comes to the agile methodology and the Scrum framework. But the idea is developing the assets and developing the code for your project. So coding, testing, programming, and the art. Essentially, all of that content generation is done during this phase. You do basic testing. We could call it like continuous testing or debugging, because you have a dedicated testing phase, which is the next phase where you stop developing and you are just getting feedback. So the main difference between debugging and testing: debugging is looking for faults in the code or for assets that don't work properly, like they're mispositioned or they go off screen or they're the wrong color. Whereas testing is comparing what you have achieved to what you set out to do. Meaning you take your premise and you say, we were meant to have 3 mechanics. Do we have those 3 mechanics? Do they work? This game was meant to be 30 minutes long. Does the game last 30 minutes or do you run out of content after 20 minutes? Or is the tutorial 30 minutes and that means it's too long? So it's about saying, here are the things that we said we were going to do. Have we actually done them? It's also like looking at the audience and saying, are they reacting the way we wanted them to? Is this making them happy? Is this making them sad? Are they, etc. After the dedicated testing phase, we have the release phase. At that point, we are looking at the handover process. So depending on whether this is a personal project, if you are one member of a team that's handing over your completed work to someone else, or whether the project is complete and you're now releasing to the audience, it's the same phase, it's just different responsibilities taking place. So the starting point would be having a handover where you properly document what you've done, and you hand that over to the next person, the next chain in the development lifecycle. You create executable files that can be actually played and extracted and utilized. And then there's also the marketing of saying, here is our game, here is the best selling points. We're going to post this on social media. We're going to put this on Steam. We're going to put this on our website. All of that falls under the release phase, and there's different people involved. But essentially, your job as a developer or as a programmer is to make sure that you hand over your work in a way that the marketing team and the designers can utilize to fulfill the release process. If you were doing an apprenticeship, you would be expected to understand this step and be able to transition from testing to release, even though you are not actually doing anything during the release phase. You just need to facilitate the people who are. With that said, there's the maintenance phase. That is to say, if something does come up, if there are problems that are discovered, audience feedback, updates to the project, or expansions to the project, you essentially go back to the beginning. You identify what you want to do, you plan it out, you implement it, you test it, you release. So the maintenance is the transition point from the end back to the beginning. If this is a one-time deal, you don't need to worry about it. But there are good maintenance practices. Things like having good quality code, good documentation, comments, making sure that if you come back to this project 6 months from now, you can understand it. This is one of the biggest things that new starters in any company struggle with, because they don't learn this. They learn how to build a project and move on. They don't learn about maintenance, which is what happens if you're now working on a different project, and then someone from your team says, "Oh, that project that you worked on last year, we're doing an update. Can you fix this glitch, or can you implement this new feature?" You look at your code and it just looks like Greek, or it looks like it looks like Chinese. You have no idea what it is because you didn't document it properly. You didn't write it very well. You don't have notes. You don't have any references that you can refer back to. You threw away or you deleted anything you didn't need anymore, and it's like it's actually worse than starting again from scratch because you're trying to imitate something. So good coding and good documentation practices will help with maintenance, and that's something that we'll talk about in future sessions. So when it comes to the different phases, there are, I would say, 3 main approaches. There are several, but these are the ones that you should be aware of. The industry standard is Agile, and the idea here is to iterate and they use the principle of failing fast. You go through each phase of development and you essentially loop back to the beginning. That is to say, rather than try and finish the whole project in one go, you finish parts of the project and then you say, how did it go? Is it going well? If it's going well, continue. If it's going poorly, adapt. Change. That's what it means by be agile. Adapt, do something different, adjust. It's very useful for projects that are customer facing or artistic in nature, where things go wrong very often. Artistic choices don't quite work out. If you think about, like, let's say films have test screenings, it's they struggle with this process, but they have test screenings, and they'll say the film is done and everyone hated it. We're going to go back to the drawing board and edit it and change it. They can't follow an agile approach very easily, and that is very costly when this happens. But in video games, we follow an agile approach. We build the game in parts, and then we say, is this working? How are people responding to it? If they're responding well, we keep going. If they're responding badly, we reassess. The waterfall approach, and this is what films tend to use, which is why they tend to struggle when it comes to, if it's going wrong, they don't know how to fix it, or it's very costly to fix. I also say this is commonly used for things like construction. It is an always forward approach. You go through each step and you never go back. This means you spend a lot more time at each phase because it has to be done to a much higher level of detail and a lot more accuracy. And then once you've released it, you're done. The reason why I compare it to, say, construction is because if you get all of your planning, permits, positions for making a building, and then you start building it, and then you realize actually it was meant to be 2 meters to the left. You can't tear it down and move it 2 meters to the left. You need to keep going and just deal with the consequences, or the project might even get scrapped completely. So you need to do a hell of a lot of planning and have a very strong idea of what the final product is supposed to look like before you ever start building it. Because once you start building it, there is no turning back. That is why the waterfall approach works for projects of that style. But you don't want to use that approach with making games. AAA studios often do because they have tight deadlines, tight budgets, and stakeholders they need to answer to. But most game studios, especially indie studios, will follow a more agile approach because they understand you can't expect a project to be built like that and for it to be a success, or it's kind of more luck than anything. The final style is worth mentioning because a lot of people do it without realizing it, which is prototyping, which is essentially you just go through the premise and planning and implement, test, and then implement and test, and then kind of just loop until you're done. You take a feature, you make it, and then when it works, you add a feature on top, and you add a feature on top, and you add a feature on top. This is a very fast and efficient way to make a product. And the reason why I say prototyping, because there's two names for it, but prototyping is the one I prefer, is because it's best used for prototypes. It's used as a proof of concept. If you just want to show an investor, or you want to complete a project for university or for school, you just need it to work. Meaning, it doesn't really matter the quality of your code. It doesn't matter how you organize things. You just need it to work. So you tend to skip out phases, you skip steps, and you get a working product as quickly as possible. But the longer you use this approach, the more unstable the product becomes. Hence, it is only good for prototyping. As soon as your prototype, your alpha, your pre-alpha is done, you basically need to start again from scratch and rebuild it from the ground up, following a proper waterfall or agile approach. That's my advice in that regard anyway. And it's also why I find it important to have these sessions, because most students at school follow a prototyping approach. And it's why they struggle, because no industry follows that approach. So as soon as they go into a professional environment, they're either doing waterfall or agile, and they're not used to it, and they struggle. So it's worth mentioning. So those are the different ways we approach the software development lifecycle, and the Scrum framework refers to how we actually implement it. So we talked about iteration. We use iteration via sprints. So talk about like the agile methodology. We break down development into a series of production periods. Each is defined as a sprint. A standard sprint is 2 weeks, but some companies will do 1 week, some companies do 3 weeks. When I'm doing a workshop, I'll sometimes do 2-hour sprints. It varies on the full length of the project, then divided down into segments. And those segments cycle through the full software development lifecycle. So your development and testing take up the majority of that sprint, but you always start and end with a premise, planning / release and maintenance phase. So I've got a little diagram here just to demonstrate what that might look like. We start with the premise and planning, which is typically done throughout a single day. You establish what it is that you are trying to do. You break those your goals down into tasks, and then throughout the course of the usually like 7 working days, you might develop some of the art, you might develop some of the code, you might do a little bit of both. There's often an order it needs to be done, because we have something we call blockers, where one thing can't be done until the thing before it is done, or we use placeholders, so we use something that allows us to keep working and then we have to change it later. But you'll see that the nature of this schedule will change over time. Each sprint, the balance will be a little bit off. Art becomes less dominant over time, programming becomes more dominant, and then eventually testing becomes more dominant, because the last day of your sprint, or the second to last day, is usually testing. And then you have your sprint retrospective, where you look back at what's been done, you tick off things that you're happy with, you highlight things that need to be addressed, and you carry those over into your next sprint planning meeting to say, here's the things that we still need to do. So when we go into the actual planning phase, we'll talk about this in more detail, but it's just worth mentioning there. So here I've got another breakdown for it just to demonstrate. So sprint planning day 1, you cover the premise phase and the planning phase. The development period, like I said, is usually around 7 working days. It will adjust over depending on your needs, and that's usually at least 1 day of testing or dedicated testing. And then the sprint retrospective is at the end, which covers the release phase and the maintenance phase. You might use the phrasing, so you might cluster sprints together into a marathon. It's not the industry term, but it's what I will refer to it as. If you are dealing with individual features, you'll usually break that down into a sprint. But if you're dealing with, say, a core game mechanic, we refer to stories and we refer to epics. So the story is the individual task that you are actioning. The epic is the larger task, the larger goal that is broken down into smaller stories. So you might say, this sprint, we're going to do these stories. And you might say, it will take us 3 sprints to finish this epic. Therefore, you might call those 3 sprints a marathon. So you cluster them together. And this is just from a time management perspective. So you organize it. It doesn't matter if you name it, but it's sometimes helpful to understand, okay, in 4 months, or sorry, in 4 weeks, we're expected to have this much done. Because you do it on a sprint by sprint basis, but you might want to plan a little bit more in the long term. So closing remarks. Hopefully by now you have a solid understanding of which roles in the industry you might be interested in, whether that's programmer, designer, artist, or any of the subcategories. What steps are followed when building games from scratch. How we organize our time to build games over long periods, so how we use sprints and how we break them down using the Scrum framework. Keep in mind this is just your starting point, and regardless of your specific interest or field that you're working with and the adjacent roles, you don't have to do all of this, and you don't have to follow this, but it is often expected of you. If you don't understand what the other members of your team are doing, you are going to struggle. And if you can show that you understand what other members of your team are doing, you're more likely to be able to get jobs and find work in the industry, because that is the expectation. You are an artist, but you should know what the designer and the programmers are doing. You're a programmer, you should know what the artist and the designer are doing. Everyone has to work together, and the more you understand what they're doing, the easier it is to work together. You don't need to be able to do their job, but if you at least understand it, it does help a lot. So if this has sparked your interest, I delve into each step or each phase of the development lifecycle in more detail. So my next video is going to be establishing a good premise, followed by the game development planning essentials. I only cover some of the basics online, but I also do events on Eventbrite. So if you follow our Eventbrite page, you'll see we do face-to-face workshops where we get directly involved and show people how to build games from the ground up, going through each phase of the development lifecycle until they have an actual product at the end of the program, and even learn about things like marketing and presentation of their work at the end. So have a look. Feel free to like and subscribe if you want to know more about our events and activities, or you want to see more videos like this one. I hope this new format works, because it takes a little bit longer for me to go through it all. And I know sometimes I get carried away and I talk a lot, so I'm open to feedback. I still prefer doing face-to-face sessions, because I can gauge people's reactions easier. But I just wanted to do a few more videos like this one, where it's just giving a little sample of the kind of topics that we go over. So hopefully you found that interesting, and that brings us to the end of our session. I hope to see you on the next one. This is Apocalyptic signing out.